Okay, so here we go. Let's take a look at the first one. So we are interpreting graphs. It says the circle graph below shows how a school distributed money. First question, how is the graph misleading?
It doesn't equal 100.
Okay, it doesn't equal 100 for one thing. And it should equal 100 because they're talking about percents, and so it should all add up to 100%. How else is it misleading?
Because like 25% is like half.
Yeah, 25% is half of it, whereas the 20% are about a quarter. So you could basically say it's not to scale in any way. Okay? What might you believe because of the graph, the way they have it drawn? Okay, it looks like they do not support the arts.
Computers is up.
Right, but math and computers, big time. But if you look at the numbers that they use, you can see that that's not correct, because math and computers is only 25% of the budget, arts is 15%, so they're not really that much different. Who might want to use this data?
Superintendent.
Okay, superintendent of schools, school board, parents, kids that want to say, hey, we need more art classes, Department of Education, anyone related to education. Okay, number 2. Mr. Shapiro found that the amount of time his students spent doing mathematics homework is positively correlated with test grades in his class. He concluded, therefore, that doing homework makes students' test scores higher. Is this conclusion justified? What do you think? Is the time doing math homework related to higher test grades?
I would have to agree.
Okay, you could argue either way here, I believe. You could say yes, more time equals more learning equals better scores. Okay, is there anybody that could say, could make an argument for no?
No.
Not really.
Why might someone spend a lot of time on their homework?
Because they're.
Yeah, because they're not very smart. Right? I mean, it's possible. So you could say, no, not really. More time means not smart. And not smart means worse scores. So this is one of those that it really just depends on the argument that you make. As long as you give good reasons, you're probably going to be okay. How about number 3? Joe found that cities with lots of police officers have higher crime rates. He concluded that as the number of police officers increases, the amount of crimes committed increases as well. So if you want to lower crime rates, you should have less cops. Is that true?
No.
No. What's really going on?
Cops don't do the job.
I think what's going on there is that the correlation is the other way around. He's saying more cops means more crime, but really the correlation is more crime means you need more police officers. So they've got it backwards there. Number 4, when boat rentals increase, ice cream sales also increase.
Oh, I have to agree with this.
Therefore, when people rent boats, they eat a lot of ice cream.
Yeah. No.
No.
I do it every day.
What is a commonality about when you might want to rent a boat and when you might want to eat some ice cream? Warm weather, okay? And that is what's called a lurking variable, which means there's something else that's making this happen. And in this case, it is warm weather. The warm weather causes people to rent more boats, and the warm weather causes people to eat more ice cream. Okay? All right, so now we've got, Some more fun things. It says a teacher gives a test to the students and they earn an average score of 75%. Describe how each of the following is affected if the teacher curves the test by increasing every score to 10%. So what would happen to the mean or the average if they added 10% onto every grade? It would go up. So it would go up, and it would go up by 10%. What would happen to the median or the middle score if all of the scores got bumped up by 10%?
Go up.
It would also go up by 10%. What would happen to the range? In other words, what the range is from the low score to the high score. So if, say, the range before was from 40 to 90, what would the range be now if you added 10% to all of them? Right, 50 to 100. So it would also go up by 10%. What would happen to the mode?
Yes, it can go up.
Well, that's a good guess. It would probably go up by 10%. Okay, and then the standard deviation we haven't talked about. But the standard deviation, if you think of the box and the whisker plots that we were working on yesterday, the standard deviation has to do with how big this box is. Okay? And so if the teacher added 10% to every score, what would happen to the size of this box? It would not get bigger. Yeah, it would stay the same. So if this were my box and whisker plot of the test scores and then I added 10% to all of them, it would now look like this. So it would be the exact same thing moved over 10. And that's why all these numbers have gone up 10%. But the width of the box would stay the same. So that means that the standard deviation wouldn't change. Okay? Standard deviation is how far everybody is from the average. And so if the average moved up, it would all stay the same. Okay, so that's a clue for number 2. A company has a particularly profitable year. The company decides to double every employee's salary. Which of the following will not change? Right, and it's A, the standard deviation. If you do the same thing to every number in the set, the standard deviation of those numbers will not change. Okay, number 3, after a sharp decrease in dairy costs, an ice cream company decides to reduce all their prices by a quarter. What is the effect on the mean and the standard deviation of all the prices of the company's products? The average will go down by 25 cents, yeah.
In the chart up here, it says no change.
That's just a typo. What happens to the mean when you lower the prices by 25 cents? It's going to go down. What happens to the standard deviation?
I really don't understand that.
Yeah, I know you guys don't. It's going to stay the same again. Okay, so it's C. Just the mean, just the average will decrease by 25%. All right. Oh, good. We get to do some graphing. Yum. So you've got some gas mileage data for a car. Okay, so here we have a graph. Somebody's speed and the miles they get per gallon. Okay? And the first thing it says is write a linear equation of the data in the table above. And so this is going to be a little bit of an estimate because it's not exact. But what is the slope of that data? How far up in this direction does each point seem to go? The miles per gallon goes up 2 from 18 to 20, right? And it goes up 3 from 20 to 23, then it goes up 2, and then it goes up 3, and then it goes up 2. So that's about what? What's the rise there on average?
1/2.
Okay, this went up by 2 from here to here.
Oh.
This went up by 3. This went up by 2. This went up by 3. This went up by 2. So the rise is about what? 2.5?
I'm still 2.5.
Yeah, because it's either going up by 2 miles per gallon or by 3 miles per gallon, and so the average in between those is about 2.5.
Oh, I get it now.
Okay? All right, what is the speed going up by each time? 5. And since the speed is in this direction, that's going to be the run. So our slope is about 2.5 over 5, which conveniently reduces to what? 1 over 2. 2.5 goes into 2.5 once. 2.5 goes into 5 twice. Okay? So now we need to use that to write an equation. So we're going to take y equals mx plus b, and we're going to plug some stuff in. What would you like to plug in for y?
3, 7, 1.
Look at the table. 30, okay? So she's going to use the very last data point, and in that one, the y value, or the miles per gallon, is 30. So we'll plug in 30 for that. The slope we figured out is 1/2. What's the x value that goes with the miles per gallon of 30? Oh, no, I'm sorry. You got to go the other way. The miles per gallon is the y, because it comes second. It goes x and then y. Okay? So when you said 30, I took the 30 from the very last one. So what's the x value that goes with the 30? 55. Plus b. Okay, so 30 equals, what's half of 55? 27.5. And so if I subtract 27.5 from both sides, I find out that b equals 2.5. So that lets me write an equation for the line y equals 1/2 x plus 2.5. Okay? So that's the answer number 1. Okay, what is the meaning of the y-intercept given this data? What's the meaning of this number right here? In other words, if I draw a line here, what we figured out is that the line would cross the y-axis at about 2.5. So what is my speed right there? Or what's my speed? 0. What is my miles per gallon? 2.5. So what that means is the answer number 2 is apparently if we weren't going anywhere at all, we'd get about 2.5 miles to the gallon, which of course is incorrect, because if you're not going anywhere at all, you're going to get 0, but it's close. Okay? What is the meaning of the slope of this data? The speed is just the x's. The slope is the change in the y's, so it's the change in the miles per gallon over the change of your speed. So I don't really know how you would describe that. Okay? Except for change in miles per gallon divided by change in speed. I don't know. Okay, using your equation, what miles per gallon will the car get at 100 miles per hour? So is my miles per gallon the x or the y?
X.
The x is the speed. The y is the miles per gallon. So I'm going to plug in 100 for the y. This is number 4. And then I have to solve this for x. So I would first subtract 2.5. So that would give me 97.5 equals 1/2 x. Then what do I have to do to get rid of the 1/2? Multiply by the reciprocal, which is 2 over 1 or just 2. So that means according to this model, if I was going 100 miles per hour, my oh, I totally did that wrong. We're supposed to put 100 in for the x. Sorry. That's even easier though. What's half of 100? 50 plus 2.5 is 52.5. So that means if we're going 100 miles an hour, we'd get 52.5 miles per gallon. Does that seem reasonable?
No.
Definitely not. Okay, so that answers number 5. How well does a linear function model this data?
Badly.
Not very well. Okay, next page. You guys love these. They're really easy. I don't know. Don't worry about it.
Number 2 or number 3?
Okay, number 1, if you look at those dots, strong positive, strong negative, weak positive, weak negative, or no correlation. Strong positive, they're mostly in a line, and they're going up.
No correlation.
So that is strong positive.
Weak negative.
Okay, number 2,
Weak negative.
weak negative.
No correlation.
Weak negative because they are going down, but they're sort of scattered all over the place, so it's hard to tell for sure. And then number 3, of course, since they're scattered all over the graph, there's no correlation. Yep, those are easy. All right, next page. Number 1, which graph represents y equals 3 times 2 to the x. So there's 2 things that you need to understand about this equation. The first thing is, where does it cross the y-axis? What's the y-intercept? Looking at this equation, you got a 50-50 chance. Wrong. 3. Okay, so the y-intercept is 3. Okay, what the 2 tells you, the 2 means that it's doubling every time. Okay? So which one of those graphs crosses the y-axis at 3 and then doubles every time? Does D double every time?
Yeah.
No, D gets cut in half every time. It's getting smaller. Okay? So it's B. What I mean, Brianna, is if you look at x equals... Right, that's what I'm trying to explain. So if you look at the graph, right here when x is 0, Brianna, when x is 0, y is 3. And then on the next one, when x is 1, y has doubled to 6. So every time you move 1 in the x direction, it gets twice as high as a y direction. Okay, backside.
What is B?
Number 2, a realtor estimates that a certain new house is worth $500,000 and will gain value at a rate of 6% every year. Make a table that shows the worth of the house for years 1, 2, 3, and 4. So if you start at 500,000 and it goes up 6%, how do you figure out how much it went up? Not divide. Usually with the sense you multiply, so I'm not going to multiply by 0.6, you're close. 0.06. I have to move the decimal over 2 places. So good thing you have your calculator now, so you can tell me what you get when you go 500,000 times 0.06. Yep, 30,000, right? Okay, so how much will it be worth then after the first year?
My calculator's wrong.
What? 530, because it was originally worth 500,000, and then went up by 30,000, so now it's worth 530,000. Okay, so we know that we know that C is out because that went down by 30,000, but it said it's gaining. Okay, how do I figure out how much it's going to go up the next time? But I'm not adding 30, and that's the trick, because it's going 6% of its current value. So to see how much it goes up this, I have to take the 530 and multiply it by 0.06. So it's not going to go up by 30,000. What do you get? 31,800. Okay, so if I add 31,800 onto this, that's now going to be worth 561,800, which is B. Why are A and D the same? Oh, it's got a different description. Okay. All right, last two, and then we're done. I know you don't. Okay, you guys aren't going to like this very much because we haven't really talked about it, but I'll just tell you the answer anyway. If you want to reflect this over the x-axis, I don't know if this makes any sense to you or not, but if you have a function like this, what's true about all my y values right now? They're going up, and they're all positive, right? If I reflect this over the x-axis, what's going to be true about all my y values now? They're going to need to be negative. And so I need to take this function, and I need to make all the answers negative by putting a negative sign in front. Okay, so that would C. If I made the x negative, then that would flip it this way because it would take all of the x's that are positive and switch them to be negative, and all of the negatives and switch them to be positive. No, because in B it's inside the parentheses, and so that's going to change things a little bit. Okay, so it's C. Yeah. Okay, and then the last one is a pretty straightforward problem. You can kind of just do this in your head. So you're starting out with a computer that's worth $4,000. After each year, it goes down in value by half. So in 1 year, how much will it be worth? 2,000. In 2 years, it'll be worth 1,000. In 3 years, it'll be worth 500. And in 4 years, it'll be worth 250. And you could write an equation for this based on what we were just talking about. Y equals, what was my starting value? 4,000. What's happening to my value every time? It's going down by 1/2, so I go 4,000 times 1/2 to the x would be my equation if you wanted to do that. Started at 4,000, got cut in half. You got that. Okay, make sure your name's on.